Alright guys, so today we are doing basically the opposite of what we've been doing all week. So all week we've been given an equation and we were drawing the graph from it. Now you're given the graph and you're going to try to write the equation from it. So what we're going to use in order to figure this out is that original equation that we looked at on day 2, which is that basic format of y equals c plus a sine or cosine times b, and then it was x or theta minus d. And we've already talked about what all those letters are, so what we're going to do is we're just going to identify those letters on the graph. So the first one of those we're going to find is we're going to find A. If you remember, A stood for amplitude. So the amplitude on my graph was the distance from the middle of my graph to the top, and that's a y value. So the height from the middle to the top. So my amplitude for this graph from 0 to 12 is 12. So on that equation, I'm going to fill in 12 for A. Alright, so the next one we're going to find is B. So B is a little bit trickier, but if you guys remember, we need to, when we're trying to draw our graph, we learned earlier that if it's in degrees, 360 divided by B is my period. So if I want to figure out what B is, I'm going to need to rearrange this equation a little bit to get B by itself. So I'm going to multiply by B on both sides. Those B's cancel out. And then in order to get B by itself, last thing I'm going to do is divide by the period. So what I'm left with is that B is equal to 360 divided by the period. So if you guys look, in both of those equations, 360 is what's on top, which makes sense because if you think about fact families, if I have something basic, like let's say I have 8 divided by 2, that's equal to 4. Well, if I flip that around and do 8 divided by 4, that's still equal to 2. So those two numbers I can just switch out, no problem. But what's important out of that is that we know that B is equivalent to 360 divided by my period. So what I can do to figure this out then is I just need to find what my period is by looking at my graph. So I can start from any point on this graph. Alright, let's say I want to start at this top point here at 0. I need to figure out where this graph will reach another high point and complete one full cycle. And it will complete a full cycle over here. And the distance between those in degrees, and this graph is in degrees by the way, I know it's not labeled, but if you're not sure, just let me know. So this distance right here is 480 degrees, and that is my period. So the B that I'm going to write in my equation then is going to be 360 divided by 480, which is going to reduce to 3 over 4. So there's my value of B. Alright, the next value you need to find is C. So if you remember, C is the sinusoidal axis, or the vertical shift, and in this case, my vertical shift, I don't have one, because my middle of my graph is at 0. So the value of C in this case is 0, so there's nothing I'm adding or subtracting to the outside of this. Now the last part is the trickiest, and it's not that it's difficult, it's just that it's very variable. So if I'm writing this equation as a sine graph, I need to find what my horizontal shift is, what my phase shift is. And if you think back to that sine parent function, the sine parent function starts at the middle, and then moves up. So the first point that I'm shifting is a middle point, and then my graph moves up. So I need to find a point just like that on my graph, and there's actually 2 places where that happens. One of those places is where I just erased, is at negative 120. The other place is at a positive 360. So I can write that equation either, remember it's x minus d, so I can write this as x plus 120 because it's x minus negative 120, or I could write that part of the equation as x minus 360, and either of those would actually be a correct answer. So the way I could write this whole equation out would be y equals 12 plus, sorry, not plus, y equals 12 sine 3/4, and then I open up my parentheses, and then either theta or x, and I'll use the plus 120. So that is one way I can write the equation of this graph. Now what makes it a little bit tricky is that there are actually multiple answers. Because let's say instead of writing this as a sine graph, let's say I wanted to write this as a cosine graph. And if you guys remember, cosine graphs start at the highest point because my cosine parent function goes like that. So when I look for a cosine is I would look for a shift from a high point. So one of those high points is up there at the very, very top, and the x value of that point is 0. So another possible answer is y equals 12 sine times 3/4 and just x, because there's no shifts. Oh, and I wrote sine when I was talking about cosine. Whoops. All right, another option would have been 12 times the cosine of 3/4, and then if I did x minus 480, because a positive 480 is another high point on my graph. That's also a correct answer. Another correct answer if I change that to plus 480, because again, that negative 480 over here, that's also a high point of my graph. So there are multiple correct answers for these. So one final change that you actually could do on this as well would be, what if I decide to write this graph as y equals negative 12 sine 3/4. So I need to look for a sine of a negative, I would need to look for a phase shift for a negative sine function. So the normal sine function starts at the middle and then goes up. But if I write it as a negative number, I'm looking for a middle point, which then my graph goes down from. So there are two locations for that. I could use negative 360, or I could use that 120. So I could write my equation this way, or I could keep everything the same and write my equation like this. Now what's important about this that you guys realize is that no matter what you use for your phase shift, C, A, and B are not going to change. Alright, so we're going to move on now. We're going to do a couple more examples. So the next one we're going to look at is this graph right here. And what we're going to look at here, we're going to find those same things on that equation. Alright, so I'm going to take that original function, which is y equals C plus A sine or cosine times B x minus D, and I'm going to fill in all of those parts that I need. So let's just go left to right and fill this in. So the first one I want to find is C. So my C is my middle, and if you guys look on this graph, my middle is at 8. So that means the vertical shift of my graph is 8. All right, the amplitude is the distance from the middle to the top or the middle to the bottom, and that height, that amplitude, is 10. So my A in this case is 10. Now I need to determine what B is. Remember, B is not the actual period itself, but I need the period to determine what B is. And this graph is actually going to be in radians. Okay, so this is in radians. So on this graph, I'm going to pick any point on this graph. Let's say I pick this point right here. I need to figure out if I start at that point, when that graph will complete a full cycle. So that graph will complete a cycle, it'll go up, and then it'll go down, and then it will finish its cycle right there. So what that means then is that one period is from that starting point to that ending point. So I need to determine how far that distance is, and that distance is 40 radians. So that's my period. Again, if you think about that, I'm going from a negative 35 to 0, that's a distance of 35, and then I'm going from 0 to 5, and that's a distance of 5. So the distance together is a distance of 40. Okay. Again, if I picked any other point on my graph, I would still get the same answer. All right. So let's say instead I looked at a high point. Let's say I went from negative 25 to 15. Well, from 15 to a negative 25, that's still a distance of 40. So no matter what point I pick, I'm going to get the same period as long as I find a whole completed cycle. So I can pick a middle point, a high point, or a low point, but it's still the same distance. So remember, B is either 360 by my period, or if I'm in radians, then B is 2 pi divided by my period. And that reduces to pi over 20. So the last value I need to find then is D. And again, D is dependent on what kind of graph I use. So let's say I'm using a positive sine graph. So if I write this as a positive sine graph, my shift is going to be a middle point where my graph moves up. And again, there are two places. The first one is at 5. The second is negative 35. So I could either do x plus 35 or I could do x minus 5. So this whole equation can be written as y equals 8 plus 10 sine pi over 20 times either of those. Let's do x minus 5. All right, another option is if I write it as cosine. Everything's going to stay the same except for the d. But I'm still keeping a, b, and c all the same values. So I need to find a cosine value that works. So I'm going to look at my graph. And cosine is shifted from the highest point. So again, one of my high points is here at negative 25. The other is here at 15. So one option is x minus 15. I also could have used x plus 25. Either one would be correct. All right, then the last example we're going to look at is this one right here. We're going to do the same thing. We're going to fill in my equation, so I'm going to find all four parts. So let's start by finding a. A is the distance from the middle to the top, so a is 4. C is the height of the middle, and my middle on this graph is right there at 7. So a and c are both based on the y values. So I look at the y-axis whenever I'm filling in a and c. So a and c are based on the y. Then when I look for b and d, those are based on the x-axis. Okay, so I've already found c, so now I need to find b, which means I need to find what my period is. So I can pick any point on this graph. Let's say I pick this low point right here. I'm going to have another low point over here at 70. So that distance is 50 plus that distance of 70. That gives me a period of 120. And because I don't see any little degree symbols on my axis, let's say this graph is in radians. So that means that b is going to be 2 pi over 120, which is going to reduce to pi over 60. And then my last point is d. And d is going to be dependent on if I write it as sine or cosine. So let's say I write this as sine. So I'm looking for a middle point before my graph moves up. So one possibility is negative 20. So I could write that as x plus 20. Another possibility is over here at 100. So I could write that as x minus 100. All right, another option is if I write that as cosine. So cosine, I'm looking for a high point. So one of my options for that would be 10. So I could use x minus 10. Or I could use either of those other 2 points. I could use negative 110 and make it x plus 110. Or I could use I could use 130 and make it x minus 130. Any of those would be correct. So fully written out, one possible equation would be y equals 4. Whoops, I'm writing it backwards. Y equals 7 plus 4 times the cosine of pi over 60 x minus 10. And that's it, guys.